So we're now going to turn our attention to the client side of the PrimeCheck app case study. And as you can imagine, we're going to walk through the various proxy and client classes that we define here to simplify the way you can program the test driver. So the test driver is actually a separate discussion we'll get to here in a second. So all the client classes like PrimeChecker client star perform synchronous remote method invocations on the server controller in order to determine the primality of large integers. And you can find that code where you'd expect to find it here. By putting the component annotation on this class, it allows Spring to be able to do things like auto wiring and so on, auto detection of various things, as we'll see here. This is the auto wired proxy. Once again, we probably could have moved this stuff into the test driver. I was just trying to keep things a little bit more clean and separated. You can make your decision if you ever implement your own code like this, what you like to do. These methods, this method here, test individual calls, as the name implies. We'll send individual requests to the server, but can do it in parallel. We'll see how that works. And let's take a look and see how that works. So here we're going to use our good friend, the stream support stream helper method, which is going to take that list of integers, convert it into a stream, either a parallel or a sequential stream. Notice for this particular set of calls, the parallelism is done by the client, not by the server. Each of the calls we make will run in a single thread in the server, although it could be mapped to something involving the use of virtual threads. But each of those calls, we're not parallelizing each check if prime call. So the parallelization is taking place on the client. And that actually leads to some interesting issues with respect to connection management. We'll talk about that in a second. Then we go ahead and make a remote method invocation via the proxy. And that will go ahead and make the call. And in this case, we're going to do this with the parallel stream mechanism here. But of course, we could plug and play that as well. When we're done, we're going to get all the results back and convert them into a list. So here you can see that we're going to send we're going to have a single call, which is going to make a bunch of calls on the server side, not the client side. And it's going to do that by passing a list of integers. So let's take a look and see how that's going to work. You can see what we're going to do here is we're going to make a single call through the proxy to the server, and we're going to pass in the list of integer objects that goes across. So the parallelism is done on the server, not on the client. And we'll see when we do the performance evaluation which one is faster. The proxy class, as usual, abstracts away the low-level details of making remote method invocations by HTTP. That was one of the questions from last time's quiz. It's important to understand why we make these designs. We don't just do them randomly to just have fun with patterns. We do it because it simplifies other parts of the code. Once again, we annotate this with the component annotation so we can auto-wire the REST template. And then we have the checkIfPrime and checkIfPrime list methods, which abstract away from all the low-level grubby details of talking via HTTP GET requests in this case. This is what checkIfPrime looks like. We pass some parameters to the server. We build the URI using FromPath and query parameter and query param for the prime candidate. So we're going to encode the strategy and the prime candidate. And we build everything up here. That's exactly like your code. And this is what it looks like under the hood if you were to actually look at what the encoding looks like. We have checkIfPrime as the route name. We have the strategy equal 1, which I forget, I think that's parallel stream maybe. And then we have the prime candidate, which is just the value that we put in there. So that's encoded in the URI. Then we go ahead and make the GET request, passing in the REST template, the URI, and the return type we expect, which is an integer. So that's going to make a call using the GET HTTP request. Here's checkIfPrime. We pass a bunch of parameters to the server, including a list. So we have to do things a little differently here. Once again, we put the right routing name there, the strategy. And now the prime candidates, we're going to go ahead and encode this to use the list to string helper method to turn that into something that gets put into the actual URI. So you can see when this call gets made, it replaces the list of integers with a comma-separated string that includes all the values of the integers. Now, then we go ahead and make a GET request to send all that stuff over to the server, and that's kind of what it looks like when it encodes in the host name and the port number the server's listening on, plus all the other stuff. A more common way to do this, just FYI, would be to use a way of passing the list parameter in the body of an HTTP post request. We'll talk about that here soon. I'm still sticking with GET requests. This is not as scalable in the sense that if you had thousands of things you wanted to send that were integers, it would make the URL too long, but it's working fine for the purposes of our test cases. So that's essentially the walkthrough of the client. Now, there's also another piece we're going to talk about when we look at the code that has to do with a connection pool. And we'll talk about why we need a connection pool when we get to the code analysis.